Okay, we have today an interesting integral. We've got the integral from 0 to 1, x squared, natural log 1 minus x, dx. Now I'm actually going to do another video generalizing this, and that other video will have, I think, a couple different methods or alternative methods and some more information. But for this one, I just want to do the straightforward thing and kind of do integration by parts on it. We have our two parts here. I want to differentiate natural log 1 minus x because it's going to be hard to integrate that without using integration by parts. So we'll use the DI method over here to the right. I'll differentiate the natural log part and we'll integrate x squared. Differentiating this, we're going to get 1 over 1 minus x. Then with chain rule, a minus sign pops out here. Integrating x squared, we have just x cubed over 3. So we'll end up with part of our solution on the diagonal, and then we'll just need to integrate this row here. So for the diagonal, what we're going to have is x cubed over 3 natural log 1 minus x, and we need to evaluate from 0 to 1. And then for the integral, and then for this integral, minus times minus is plus, and I can pull 1/3 out front. So we're integrating from 0 to 1 of just x cubed over 1 minus x. Now for this thing right here, we could go ahead and try to evaluate it. At 0, it's fine, but at 1, it's going to be a problem. So I'm going to leave it for now and see if we can combine it with some other terms in order to make this work. So then focusing on this integral, if I want to get some cancellation, this will work if I subtract 1 and factor, but I don't want to change it, so let's add 1. And so then with this plus 1, let me make some space and we can split that plus 1 off into a separate integral. Distributing plus 1 to 1/3, we're going to have just plus 1 integral from 0 to 1, and this second integral is just 1 over 1 minus x. But now this one's going to be pretty easy because integral of 1 over 1 minus x is going to be natural log 1 minus x, and a minus sign is going to pop out evaluated from 0 to 1. But notice we have this in common with this here. We also have the 1/3. So it's going to be pretty easy for me to just take this and combine it with this one right here and evaluate these together. So doing that, all I need to do is just change this to x cubed minus 1. And then combining these and then writing it like this, now we're actually going to be able to evaluate this thing. So like I said before, the 0 is going to be nothing because you're going to end up with natural log of 1, which is just 0. We just need to focus on this 1. But if you just plug in 1, you're going to have an indeterminate form because this first part is going to be a 0. This second part is going to be natural log of 0, which is going to minus infinity. So then for this whole thing here, what we need to do is evaluate it as a limit. I'll take the 1/3. The 1/3 is not going to bother us too much. So I'll bring that out front of the limit as a constant. And we need to evaluate this as x is going to 1. But 1 from below, not that, I don't know if it really matters, but we want 1 minus because we're looking at values just less than 1. And then for the rest of it, let me rewrite, but let's take the x cubed minus 1 and bring it into the denominator. The reason I'm doing that is because I want to set up L'Hopital's rule. Writing it this way, the numerator is going to be going to minus infinity, and now the denominator is going to minus infinity. So for L'Hopital's rule, I just want to differentiate numerator and denominator on this. For the numerator, we get 1 over 1 minus x, a minus comes out. For the denominator, we get minus. This is going to become x cubed minus 1 squared. Then chain rule, this is going to be 3x squared. Cancel minus with minus. Flip this, bring it into the numerator. But now at this point, it's still an indeterminate form. All I need to do, x cubed minus 1, I can just break this out. X cubed minus 1 squared. We can separate it, then we can just take one of them, factor that, write it as x minus 1, x squared plus x plus 1 times this other piece. But then let's put this together now with this denominator. So we have, I'll go out of order here, we'll have 3x squared, and we'll have this 1 minus x. But then I can cancel this with this, and we just need to bring a minus sign out front because we've got the sign reversed. And so let me rewrite it. I'll bring the minus sign all the way out front with the 1/3, and we're looking at the limit as x is going to 1 minus of x squared plus x plus 1, x cubed minus 1 over 3x squared. But now we can just basically plug in and evaluate this whole thing. So we have minus 1/3. Plugging into the numerator, that's going to be going to 0. And then here, this is going to be going to just 3. So putting it all together, this limit's going to be just 0. And then this whole piece right here goes away. This is all 0. So what that means is we just have this fairly simple integral that we can just evaluate in order to finish it off. Okay, now for this integral, I can just factor the numerator the same way we did a minute ago. Let me also, just to set this up, I'll factor a minus sign out of the denominator. So then we can write this as x minus 1. Then for the numerator, again, we'll write it as x minus 1, x squared plus x plus 1. But then cancel x minus 1 with x minus 1. And now all that's left, it's going to be really easy because this is just power rule now. We're just doing x squared plus x plus 1 dx. Integrate on it, minus 1/3. This is all going to become x cubed over 3 plus x squared over 2 plus x from 0 to 1. When you plug in 0, that stuff's all 0. Plug in 1, what we have here, minus 1/3, 1/3, 1/2, plus 1. Next, get a common denominator and everything. We'll do this, everything, we'll put it over 6. So we'll have 2 6, 3 6, 6 over 6. This right here, this is just 11 over 6. Multiply 11 over 6 times minus 1/3. For my final solution, we get just minus 11 over 18, and that's it. Okay, there you go. Good one today. Straightforward methods, integration by parts. Thanks everyone for watching. Have a good day.